Good afternoon, everyone. Actually, Marilor and Vittorio has spoiled my presentation because in their presentations of the OCTAC and of the marine forecasting centers, there are actually results that were produced by projects in the Service Evolution. So, okay. In fact, my duty today is to present what has been produced in the Service Evolution Green projects and how they benefited CMEMS. So I will give the examples of the three projects that were being delivered in the first Service Evolution batch: Massimilli, Tosca, and Green Up. It's quite interesting, these three projects, because give us the opportunity to show how the Service Evolution operated at in advancing the science and improving the products for key levels of the trophic web. In fact, let's say that Massimilli impacted mainly the biogeochemical and the chlorophyll as a representative of the phytoplankton community as a whole. Tosca improved the representation of the phytoplankton functional types that compose this community, and while Green Up looked at higher trophic levels, Micronekton, and with hooks to up to fishes and big mammals. So let's start with Massimilli, who had the objective to develop a biogeochemical data simulation system for integrating biogeochemical Argos data that look at the depth of the water column with ocean color into the operational model of the Mediterranean. So they started by improving the assimilation of chlorophyll extending from the open ocean into the coastal area, so that they improved and the simulation of the primary production and chlorophyll at the surface. Done that, they started and they developed a system for the assimilation of biogeochemical Argos, chlorophyll, and we see on the top right an example how it's important to get the maximum, the deep chlorophyll maximum at depth that the satellite cannot see, but the biogeochemical argon can catch. And by assimilating this data, they managed to improve the simulation of chlorophyll at depth, but not shown here, also nutrients, for example, nitrogen, which is also measured by biogeochemical Argos, and that they have compared with their model simulation. But doing this required quite a lot of work to optimize the assimilation system with respect the frequency of assimilation, the error estimation, and also which one was the horizontal scale of the radius for which doing this such assimilation. So they performed some sensitivity analysis on which one was the ideal assimilation frequency, exploring from weekly to daily. They found that switching to daily, they improved the root mean square deviation of the preyl, but the number of biogeochemical Argos available for the assimilation were obviously lower. They explored the sensitivity to the radius of the horizontal correlations, and they found that 15 kilometers was the one good, because two larger would have created spurious correlations that actually would have not improved the system, despite a larger area of the Mediterranean would have benefited in terms of just corrections. And then they they assessed the comparability of the biogeochemical Argo chlorophyll with satellite product, and the correspondence was not obvious. So for sure there is something to do and to work in assimilating both the products. This assimilation of biogeochemical Argos will become operational in the second quadrimester of 2020. So, and we have already seen talking about this in the presentation of Marie-Laure. And it was demonstrated biogeochemical Argo improved the representation of the vertical dynamics, chlorophyll, but also nutrients. Multivariate assimilation, where both chlorophyll and nitrogen will be assimilated, is ongoing. And this is quite an interesting thing, because the daily, I didn't mention before, daily assimilation of biogeochemical Argo allows you to assimilate simultaneously the physical and the biogeochemical parameters measured by Argo, and so getting that consistency between the two types of information, which is so much important, because physical data assimilation alone can be actually can also deteriorate the simulation of biogeochemistry. So this is a very important aspect. And then the simultaneous assimilation of biogeochemical Argo and chlorophyll from satellite requires quite a lot of attention, but can be very useful. So we have been, and this work has been published in the number of papers, 3 exactly. TOSCA, it's another service evolution project that looked at the phytoplankton groups composing the phytoplankton community, because the different phytoplankton groups, diatoms, dinoflagellates, and nano and pico, since they have different biogeochemical functions, they impact in different measures the biogeochemistry of the system. So it's important to get these groups well, to have a good prediction of the functioning and of the system and of biogeochemical indicators. So PFTs can be observed from space, can be predicted by models. This was already published. TOSCA, for the first time, proposed the assimilation of PFTs from ocean color into biogeochemical models for operational purposes. So, first of all, a regional product for the ATL region was developed. The work was published by Bruin because it brought quite a lot of novelties. One was, for the first time, PFTs were characterized by error, were characterized pixel by pixel, so providing information on the reliability of this product and providing important information for their assimilation system, which accounts for this error. So the TOSCA, the software that was developed in TOSCA for the production of PFTs was directly transferred to CMEMS, and actually CMEMS OCTAC will produce in 2019 PFTs in the ATL, Arctic, and global region, in the Mediterranean as well, actually with a different algorithm not developed in TOSCA. In 2020, global will be updated PFTs, and in 2021, also in the Baltic and in the Black Sea will be produced. But these products were also assimilated, at least for the Atlantic region, in the operational system of the Northwest Shelf, which used NEMOVAR. And these, I will not go in the details of these graphs, but they want to just demonstrate that its assimilation of PFTs outperformed the assimilation of total chlorophyll, which is the standard product, in providing 5-day estimates of the PFTs. Remind that some PFTs can be linked to harmful algae blooms, so just the fact of getting right predictions in 5 days of this product can be useful for application like harmful algae bloom prediction. But also we managed to improve PCO2. The other graph on the right shows this. PCO2, which is an essential climate variable, and the argument came out today about ocean acidification. It's a variable related to ocean acidification. So managing to improve this variable by assimilating ocean color, it's quite an important result. So the TOSCA data assimilation system was transferred to the Northwest Shelf MFC, and the assimilation of PFTs for reanalysis, it will be a reality in 2019, and it will become the standard for forecast in 2020 in the Northwest Shelf. What I want to stress is the system would be transferable to other domains, I believe, like in the Mediterranean, where a PFT type of model is used, or also in the global system, where Pisces is using a PFT approach. So why not assimilating there as well? Published in other 3 papers, this work. And then we pass to we do another step on the trophic scale, and we pass to green up low and mid trophic levels, where which produced another project which produced Zooplankton, Micronekton. Micronekton are those fishes up to 20 centimeters, or squids, or that can swim, but they are still small, and which are very important because are the link between the lower trophic levels that we have talked up to now, zooplankton, chlorophyll, and so on, up to fishes that eat, or big mammals that eat such microplankton. And these greenhouse produce this by means of an advection, diffusion, and reaction model, and which uses temperature, currents, and primary production produced by CMEMS, or that is producible by CMEMS, to provide estimates of the biomass and the production of one zooplankton and 6 micronekton functional groups. And these then can be linked to models that, like Cepodim, that can simulate habitats and population dynamics of fish and large mammals. So I said 6 functional groups of micronekton, which are related to their capacity to vertically migrate, because zooplankton does the biggest movement of animals in the world, more than wild beasts in the Serengeti, I would say, because they try to avoid that day to be predated at the surface, so they go at bottom. So on the base of this capacity, 6 microzooplankton have been classified and used in the model, and this required a big effort of parameterization and a new method using acoustic data and zooplankton data have been applied for a kind of offline data simulation to estimate the parameters of this model. And here we have an example, a first example of application of the microplankton, micronekton that is produced by this project. Here we have the dynamics of tuna stock and fisheries in the Pacific that has used the micronekton as an explanatory variable to produce this map. These are skipjack density at a quarter resolution, weekly data in the Pacific. And this information is very useful because using this kind of model, you can also create kind of scenarios apart stock estimates, but also you can do scenarios of impact of fishing, impact of climate variability, and spatial management. For example, in the graph on the bottom right, you have 2 different scenarios of fishing and no fishing based on the micronekton as an explanatory variable. And another application, mapping of habitat of big mammals, like example, whales on the east coast of the United States. And we have also a quote by a user of this product, Jason Robert, that said that the use of micronekton as an explanatory variables, it brings the model, their model to improve much more the results than using simply the chlorophyll as they did it before. And for example, these results was useful for the US Navy because they have to provide an assessment of how many mammals will be taken during the exercise. I think this is an euphemism to say bombed. I don't know. It was a little bit sad. So for the sperm whales. Yeah, these are just the conclusions. I want to stress that this cross from the CMEMS service evolution, passing through the different trophic webs, producing biogeochemical Argo assimilation, PFT production, micronekton prediction, and with an overall improvement of the ecosystem science and possibly of variables that we can put in the catalog. Thank you for your attention.